So let's start on a design that we can find in our design requests section on the website. So the top one here is a 5-volt power supply, and the description is something that it's powered off a 5.5 millimeter jack, and it can accept a DC voltage range, and we also want it to be able to fit into a breadboard, so we can use it for prototyping purposes. And then also some terminal blocks like screw terminal input and output would also be handy. So we're going to use this as our basic guide for our design. So let's go into KiCad and let's start a new project. I'm going to just go into my documents and we're just going to name this 5V 5-volt breadboard supply, and I'm gonna also name my project that. And there we go. So you can see here it's created the .pro, which holds all the project information. There's the PCB file and the schematic. And right now we're just going to focus on the schematic. So let's go in here, and this will bring us into EE schema, is where you edit your schematics. And now we can start placing parts, but I haven't talked about what parts we want to use yet. And so the best place to start when you're trying to figure out what parts you want to use is the universal parts list. So we need some sort of voltage regulator, so it would make sense that you would look in your regulator category. And right there we see this 5-volt voltage regulator that can output 1.5 amps, and that should be more than enough for any breadboard application. So let's look at the data sheet. And normally the data sheet can give you a lot of information on how to make a circuit that uses this part. So if I scroll down a little bit, and this is obviously the innards of the circuit. That's a schematical representation of it. And then here is the start of the application circuits. And this is the most basic one, where we have a 0.33 microfarad on the input and a 0.1 microfarad on the output. And these capacitors are really here to filter out noises either by fluctuating supply or fluctuating load. And that's all there is to it. Of course, there are more advanced circuits like load regulation, ripple rejection, and if you scroll down, there's even more. But we're just going to look. We're just going to go with this very basic minimal part count design of this and 2 capacitors. And of course, we'll have to add some other stuff, but just to start out with, we'll add these. So in our schematic here, we're going to click here to place a component. And oops, we've made a mistake. We don't have the Open Circuit Institute libraries included. So let's go ahead and do that real quick. When you want to go to Preferences, Component Libraries, and we want to add. And now we need to navigate to where you have those saved on your computer, where mine are in my Documents, and then OCI Symbols. And now I want to just click here, and then Shift, click here, and I want to add all 10 of these libraries. And now I can see they're all down here right at the bottom. Now I can add my LM7805, which is going to be in regulators, and right here 5-volt reg. Click OK to add it, and now we can just place it somewhere in the middle here. Alright, now we need some capacitors, so we're going to place component, and let's just look through our libraries. Right there is our capacitors. And we might not have the value that we need, so we need 0.33 micro. We have 3.3 micro, and we have 33, but I don't think we have 0.33. So let's for this, let's go with well, what should we go with here? Sometimes it can be better to look at it here, what our selection is. So we want 0.33 micro, so we got a 0.47 micro is the closest we can get. So let's add that one, 0.47 micro. And with a lot of these capacitors, unless it's something that's timing sensitive, the value, if it's close, it doesn't really matter. And then for other capacitor value, we need a 0.1 micro, which we should have. So let's just click here. 0.1, right there is our 0.1 microfarad. And there we go. I'm actually going to move these down a little bit because it makes our routing look a little bit more clear when you do this. Alright, so we want the 5.5 millimeter jack for the input. So I should just be able to type in 5.5, or there's my there's my jack right there. And this is in the UPL, so I'm just going to double click it. And there we go. So now I need some sort of output, which I specified those are going to be header pins, and so I can find those in the connectors library. And I don't want them to be female. That's what this FEM stands for. I want them to be male. And I want to connect. If we look at a breadboard here, I want to connect to this point here, or these 2 points, and these 2 points. So I'm going to need 2 sets of 2 pins, and this will give it a fairly tight grip on the breadboard. So we're going to go with male 1x2, and click OK. And I'm gonna I could place another one, or I could scroll over this and press C to copy, and there's my second set. So let's I'm actually going to move these guys down a little bit out of the way, because we're going to have some interesting routing for those. And then the last thing is we wanted to have screw terminals as an alternative input and output, so we don't necessarily have to have this in a board or in a breadboard. So we can go here and just type in screw, and there's my terminals right there. So I'm gonna place these right here, and I'm also gonna have some on the output. I'm gonna place it right there. Alright, and the last thing that we need to add is some sort of indicator that this circuit's working. It's always a good idea to have like an LED or something saying, hey, your circuit is powered up and at least should be functioning properly. So to do this, if you go to LED, and we want to make sure that we take out of the UPL libraries since everything's already defined, and we're going to use a red LED. Actually, no, let's use a green because that indicates power. I'm going to switch it to point down by pressing the R key. And we also need a resistor in here to limit the current. And normally we just use a 1K will work for most. Just something to limit the current a little bit. So we're going to put it there, and I actually want to move all these two components down a little bit. So all I had to do was make a bounding box around it, and then I could move downwards. Alright, so now, well, this is something I like to do. I like to get all the parts out and position just about where I want them before I start actually wiring things together. So let's start doing that. So this is going to be our positive input. So what I'm going to do is I'm going to press the W key, or alternatively I can click over here to place wire. So if I press W, and I got to be careful that I'm in the spot where I want to start routing when I press it, and then I can click, and now these 2 points are connected. Now I want to add this capacitor on there as well. And I can see there's a dot indicating that there is a junction or a connection between those 2 points. I also want my pin 1 to connect with this as well on my terminals. And then we're going to have a V out of our regulator go all the way to pin 1 on these screw terminals. We need to wire this capacitor. We're going to have our indicator LED, which is going to go through this resistor to the LED. And then we've also got our header pins that need to be wired. Now, all the rest of the connections are ground. So to get our ground reference, we need to click Place Power Port. And I'm going to click, and I'll just type in GND. And here's our ground symbol. Instead of doing that process over and over again, what I like to do is I like to scroll over the ground, press C, and copy. And I'm going to do that everywhere I need a ground. I just keep on scrolling over it, pressing C. I just keep going. There we go. Now all I have to do is wire these. These 2 pins are connected here, so that means that they can all be connected to ground. Oops, so I'm going to cancel out of that. What happened there, I was in my Place Power Port mode. So it's a good idea after you're done using one of these tools on the side to just press Escape a few times, and you'll see the green box go up to the cursor there. And then once again, to wire, it's the W key. So I'm going to scroll over this point, and we're going to place some wiring for that. Wiring for that. This ground. This ground, this ground, oops, this ground, ground, and the last ground. And there is a complete schematic. So we have power can either come in through this barrel jack, or it can come in through screw terminals. It has a 0.47 microfarad capacitor to filter any noise that we might get in there, so it doesn't show up on our output. And then we also have this capacitor on the output of our regulator to prevent, it's just for more noise prevention. Then we have an indicator LED to let us know if there's power coming out of this. And we have 2 sets of male header pins which will be connected to the breadboard, and we'll also have an output screw terminal that we might be able to connect to other devices, perhaps a motor or something along those lines, or at least a small motor. So before we can move to our circuit board, what we want to do is we want to annotate this schematic. And what that means is you want to apply numbers, like you can see this U question mark, con question mark, C question mark. So we need to apply unique numbers so we know that this C is different than this C. So to do that, we're going to click right here, Annotate Schematic Components. And normally I just keep these all at the default. So I'm just going to click Annotate and just say OK. And now you can see we have all of these parts have numbers associated with them, or we call them designators. And of course, it's a good idea to save frequently. I'm surprised I haven't saved yet. So I'm just going to click here. And the last step we need to do here is generate a netlist. And what a netlist is it lists all the components you have, and it knows what pins are on the component. Like you can see here, this regulator has a pin here, here, and here. And it can tell, or it records what connections are between components and their pins. So it will record that pin 1 on the barrel jack is connected to the VI pin on the regulator, and so on and so forth. And this information is used to tell you, or essentially help you in the process of making your circuit board when you're laying it out. So it's pretty easy. All we have to do is click here, generate, and it asks you where you want to save your netlist, and I usually just save it right in the same file as everything else for the project. Click Save, and now it is completely ready to route into a circuit board.